Project 62 is Tri-Light Funky Siren. Now, in case I didn't mention earlier in the previous video, I am not going to do projects 58 through 61 because they are variants of 57, which I already did. Likewise, I am going to do 62 but not 63 through 66 because they are variants. What we need to do is turn on the slide switch and select Game 21. And you will see that the three LEDs flash while the speaker makes a very weird siren sound. This is the police car siren, and you will notice, if you look carefully, that, well, two of the LEDs are on, one is off. In other words, the three LEDs are not all on at the same time. The single LED that remains off while the other two are on is the green LED. The green LED will be off while the other two LEDs are on, and then when it is on, the red and yellow LEDs will be off. Project 67 is Hex-Light Funky Siren. As you may be able to tell, I added the disco motor, and we will select the same game as the previous project. And now you will notice that in addition to the three main LEDs, when the siren sounds, the disco motor lights up as well. All three of its LEDs are on. Now I can't tell whether they are on at the same time as the green LED or as the other two lamps. Project 68 is called Pent-Light Funky Siren. When I program this circuit, the blue light on the disco motor will be very dim. Now be aware of the flashing lights, but I am just showing you how dim the blue one is. That is because in this circuit, the disco motor will receive less voltage, and therefore the blue LED will be very dim. Project 72 is called Random Funky Siren and Lights. For this project, we're going to select Game 2 instead of 21, and you can use any of the previous projects that are listed. But, as you will know, I did not do 69 through 71, because they are the same as either 67 or 68. 72 can use any of the previous circuits. The circuit will perform many different actions, such as flashing lights, the U29 display changes, and the siren goes on and off. I used the Project 67 circuit, so the blue light on the disco motor will stay on. Project 73 is Siren Arcade. This project has 5 other variants, which I am going to demonstrate. So these are projects 73 through 78. Using this circuit, I'm going to turn on the slide switch, and you can hear a siren. Now, it's not very loud because of the other components I am using in the circuit, but we're going to select Game 1, and there are other functions that take place as well, like winning and losing arcade sounds and the LEDs flashing on and off, in addition to the siren. This is a police car siren. The display changes too. '74 involves the second sound, which may sound like a jackhammer. You should hear it. The rest of the effects in this project and the following three are the same. '75. I made a different connection. Now we have a fire engine siren. There it goes again. '76. This is a European siren. It's also possible for the sound effects from the speaker to overlap. You could hear that the traditional arcade sounds were playing at the same time as the siren. That's pretty interesting. '77 has a sound comparable to that of a space battle or static. '78 is Fast Siren Arcade. For this project, we can use any of the 5 previous circuits, but we will reset the U29 display and input game 2 or 3. This will cause the sound effects to switch faster. I'll do 3. Look how quickly everything changes around. As you can hear, I chose the fire engine siren. It sounds pretty weird with everything changing so rapidly. Project 79 is Disco Siren. This project has 3 variants, which I am not going to demonstrate because they don't seem to work. I tried them before, but I am going to demonstrate the main project, and you will hear a police siren. When you turn on the slide switch, the police siren sounds and the disco motor powers up. I'm going to move the circuit into a darker area so you can see the disco lights better. It's a little bright, please pardon me. But what's interesting is that if you look at the top right of your screen, you'll see the reflections of the blue, green, and red disco LEDs. I think it's from the light reflecting off of the camera lens, but I'm not exactly sure. 83 is slow speed disco ball. Unfortunately, I don't have the disco motor, as I may have said before. The disco cover attached, but I can show you the principle of this circuit. We're going to turn on the slide switch, and you may be able to tell that the disco motor rotates very slowly. Now, when you press the S2 switch, the motor rotates faster. Now release the press switch, and the motor slows down significantly. Here you can see the colors of the lights better, but they may be bright, so they may be a little uncomfortable. You don't have to look at them if you don't want to. Now, I think the speaker here is used as a resistor, and it does not have any other purpose. 84 is similar to the previous project, and it is slow, fast disco. It has the slide switch and press switch, but it uses the PNP and NPN transistors. They play a very important role in this circuit. When you turn on the slide switch, the disco motor is pretty slow. But when you push the press switch, the motor will spin at full speed. When you let go of the press switch, the motor slows down again. How does this work? That is because the transistors act like a speed bump, which reduces the voltage to the disco motor. When you push the S2 switch, the transistors are bypassed and current flows directly to the motor. Electric current will always take the shortest path. This is the long path, because the short path is blocked. However, when I push the press switch in, then it now takes the shortest path. Even though the longer path is still an option, it's going to take the shortest path. Now it has to take the longer path again. 85 is not so slow fast disco. For this project, I added a 2-snap wire and over here, and now the disco motor spins a little bit faster than it did on the previous project. I'll actually take the snap wire off, the 2-snap wire off, and now the motor is a little bit slower. Put it back, and it rotates a bit faster. That is because the 2-snap wire bypasses the Q1 transistor, so current can flow through the Q2 transistor, but this speed bump is not enough to block the current so that the motor spins as slow as it did in the previous project. Pushing the S2 switch will allow the motor to rotate at full speed. It will bypass everything. 86 is dimmer disco. For this project, I moved the blue jumper wire from this point over here. And so now less current gets to the LEDs and they are dimmer, because the current now has to flow through the transistors to power the LEDs as well as the motor. Hitting the S2 switch will bring the lights to full power. The blue light is affected most since it requires the most voltage. The LEDs are now part of this speed bump. 87 is super slow disco. Similar to the previous couple projects, we turn on the slide switch, and this time the disco motor does not spin. although the LEDs come on. When you push the S2 switch, the motor will spin at full speed. And also, it is supposed to spin at very slowly on its own after you release the press switch. That is because you need to give the motor some momentum to spin when a very low voltage is applied to it. As you can see, I applied the speaker, and although it makes a little bit of noise, the primary application is to limit the current. The speaker acts like a resistor, and now the speed bump for the current to get to the motor is even bigger. Hold the press switch down, and everything is bypassed. For this project, you can compare the patterns produced by the disco cover and lights when the motor is spinning slowly or quickly. Now, if the motor doesn't remain spinning after you push the S2 switch, you can replace your batteries or put the orange jumper wire between these 2 points. But if the motor continues to spin slowly after releasing the S2 switch, then you do not need to do that. Project 88 is called Slow Fast Word Fan. As you can see, I replaced the disco motor with the programmable fan, and I am going to turn on the press switch. I am still using the Q1 and Q2 transistors. When you turn on the slide switch, the fan may slowly spin or not move at all. Now, I don't recommend you doing this by hand, but you may have to give it a small spin yourself to get it going. But always keep your fingers or hands clear and other body parts clear of the fan blades. Now, the transistors once again are acting like a speed bump and preventing full current from getting to the fan. The fan is not spinning fast enough in this case to display messages. Maybe if the batteries were newer, they would, but when you push the S2 switch, the fan is on at full speed and it will cycle through all the phrases that you have entered. It's just the first slot, which is 6. Release the press switch, and the fan is still spinning slowly, but it's not showing messages. Project 89, a variant of 88, is not so slow fast word fan. I put a jumper wire between these 2 points, and I'm going to turn on the slide switch and see what happens. Even when the press switch is not activated, the fan spins a lot faster, although not at full speed, and you can see the messages. 6. In this instance, Q2 is bypassed, so it will not limit the current flowing to the programmable fan. And there's my name. Now the fan is at full speed and the messages are at full brightness. Project 90, another variant of 88, is slow fast fan. The only difference that you notice is that I switched the programmable fan so that it is now facing the other way. I connected it in the opposite direction. You can use either 80 or 88 or 89 for this project, and I'm going to still use 89. The fan rotates fast. I'm going to actually disconnect the jumper wire. The fan slows down, and then I can push the S2 switch, but you'll notice that the messages are not displaying even when the fan is at full speed. That is because the LEDs, which are used to display the messages, only allow current to flow in one direction. So the fan will continue to spin because the current can flow through it in either direction, but the LEDs will not work in both directions, only in one direction.